Welcome back to Ox Tools. I'm Tom. So thanks a lot, guys. You really liked that video I put out on the Stalingrad tractor factory pliers, and appreciate all the views and all the comments. I try to respond to a lot of the comments, and I appreciate it. Thank you. So guess what? It spawned another tool repair project. Another fellow at work, a friend of mine also, a mechanical technician and that works in the superconducting magnet group. Hi, Chet. His grandfather worked, I think it was his grandfather, worked for United Airlines, and in the Bay Area, San Francisco Bay Area, and they have a large maintenance facility that's been there for a very long time. Anyway, he worked there, and so we have a snap-on Ratchet, very old, that needs repair. So we're going to check that out and see if we can fix it for Chet. Once again, sentimental value, kind of a neat story, and a fun little repair project. So other announcements. This is Father's Day right now. Happy Father's Day to all the fathers out there. Next weekend is the Bar Z Bash, which I go down to Southern California, and we have a YouTuber get together. Keith Rucker is going to be there, Dale Derry, a few others, and myself. We have a big swap meet. There's there's all kinds of raffles, all kinds of stuff going on. Here's the website and the date. I'll put that up there for you on the screen. You can check that out, and it'll also be in the description. If you want to sign up, I think it's like $30 or something like that for 2 days. You get lunch, drinks, some raffle tickets, meet and greet all your YouTube friends, a bunch of stuff. So if you're in Southern California area, highly recommend it. Check it out. And Stan Zinkowski is the host, and he's a good friend of mine. So check it out. So let's take a look at this this Ratchet and see if we can bring it back to life. All right. So here it is. And there's the bits and pieces. And this is a snap-on Ferret F-70N, and I looked it up, and there was a little advertisement online that you could see, and they called it a Ferret. They made a bunch of wrenches and ratchets, and it was kind of a series of tools, I guess, that reached into, they could ferret out the fasteners. I guess that was the sales line there, made in the U.S. Here it's got his grandfather, I think it's his grandfather, I have to double check, Spencer. You can just barely see it there. And then the date code is in here, and this dates to 1940, which so it has some historical value. It's got a kind of a dirty patina on it. We'll do a little cleaning inside here, but we're not going to polish or do anything like that. I'm kind of against that. Now, what's interesting about this particular 3/8 drive ratchet is it's got a brass selector lever, which is pretty cool, actually, I think, and that's pretty special. And then, unlike a modern ratchet, it doesn't, the socket retention ball, and that's what we're fixing, by the way. It looks like somebody kind of went after it there in the past, but in the modern ratchets, they actually upset and stake the steel itself with a spring underneath it to retain the ball. Now this looks like it had some little, oh hey, lucky me, some little brass insert, and now we got a, I don't know, relatively clean hole. Okay, well that's good news, and because that's what we're going to make, a new insert with a spring and a ball, so that we get our socket retention back, and then we'll do a little just kind of maintenance cleaning in here to clean this crud out and put it all back together. So it's cool because he still has the original screws. This is intact. It's all original. So what we're doing is, I don't call it a hidden repair, but it's kind of a transparent repair, right? You don't see it as part of the restoration. So let's do a little measuring and let's make a little sketch. All this stuff starts with a sketch, and then we'll get going. So here's its modern contemporary here. Actually, I didn't look up the date code on this one here. This has got a stylized 7 here. Online there's a little chart with all the date codes, but I bought this Ratchet in 86 or something like that, 1986, I don't know. But you can see the design similarities there, right? Very, very similar. The reason I drug this out is I want to get some idea of the ball diameter, right? So this is crimped in, and you can kind of see that, right? Where they actually just upset the steel around it here, right, to retain the ball. And it's got a pretty stout spring behind it, so hopefully I got a spring kicking around that we can use. But let's get a ball dimension here, and I know it's a little bit bigger than what I see on the surface here. So I'm gonna guess that looks pretty good there. Okay, well that's good news. It's a 3/16 188 diameter ball, and for our metric folks, that's 4.7 millimeter, 4.77 millimeter ball. Let's go find a ball, and I'm pushing on that. Yeah, that's a pretty studly spring, and I think, you know, for socket retention, I think that's pretty important that you have a pretty stiff spring in there. In that, so all right, so we're going to look for a ball and a spring in our parts bin engineering. Let's see what we got here. Gonna need those. I'm gonna guess that looks about right. Okay, first try. It's 187. Okay. Another one there. Interesting. Okay, well, that'll work. Alright. Alright, let's see if we can find something here. Ooh. That's about the right diameter. 178. It's a little smaller than the ball, which is kind of what I want. It's a little long, but we can always cut that off. Oh, what do we got there? Oh, it's too big. All right, I have more springs. So this is one of those things, you know, if you do a lot of, I don't know, prototyping and tinkering and stuff like that, you know, a selection of springs is kind of nice to have. This came from an estate sale. There was compression and extension springs, but I got some more. So the others, that other tray was those were stainless steel springs. These are steel. Okay. Looking pretty good. Ooh, what do we got there? That looks pretty tasty. Oh, those all the same. So a lot of these companies like Lee and Century and I think those are all the same. I can't think of the other one. But if you go on their websites, they have ooh, there's a nice looking one. What else? Anything in there? No. Okay. I think that's the same as that one. Yeah. Okay. So let's see which one we want to use here. Ooh, that one looks, boy. Oh, that's a pretty stiff one there. Oh yeah. Yeah, you can see the wire diameter is larger on that one. Length looks pretty good. Let's see that one. Yeah, okay. Okay, those two are the same. Now what do we got here? Okay. I think what we're going to do... Alright, so these are our three candidates here, I think. Our three candidates. I'm gonna squeeze them a little bit and see which one I like the feel of. So what we're going to do here is I want to displace this ball a little bit and get some idea of which one of these springs is going to be our best bet. I'm pretty sure I know which one we're going to use, but I just want to calibrate my my little crawdad pinchers here. So what I'm going to do is I'm just going to displace the spring and measure the force here with this little force gauge. That's a pretty stout spring. I'm traveling about a 1/16 of an inch and 7 or 8 pounds, something like that. Okay, so that gives me some, let's see, now I need to, let's see if I can, you guys can't see the, let me, I'll move the camera a little bit, but here's what we're going to do. We're just going to push down and displace about the same amount. Alright, I can already tell you that that particular spring is a little soft here, but let me set the camera so you guys can see it. We got our first test spring here. Oops, by crud. All right, get it centered up there. Yeah, that one's pretty soft, 4 pounds, and I think I'm probably displacing a little more. This is just to give me kind of a relative. Let's try this one here. Comparison between these, right? Oop. Make sure that the switch doesn't lock it. Yeah, this one's about the same. Okay. Also, what I was saying a minute ago was these spring companies that sell springs, a lot of times on their website, they have a, I call it the floor sweepings bag. So you can buy a bag or a box of assorted springs. It's literally they're overrun, or like I said, you know, what they sweep up off the floor and then put in a box, right? And you can get a nice little prototyping assortment. Okay, now we're talking. So this is pretty close to the other one, or the one that's in that ratchet. All right, we just found our spring, I think. Okay, yeah, I like this one. And you can see, hopefully you can see the difference. These, come on. The wire diameter is larger in that one. All right, well, they love each other. We know which one we're going to use. So we got our ball, and we got our spring here, and this spring is pretty close to the original, because there's, and it's hard to see down in there, but there's a little step, a little centering seat that this just happens to fit into quite nicely. And this spring, you know, when we make the retention feature, right, this will preload this spring but still allow some travel. So it'll preload it and then still allow a little bit of travel to get the socket on. So now we just need to make, I'm going to call it a retainer. And the old one, here's, oops, where'd the old one go? Oh, there it is. The old one was made out of brass, so we're gonna do the same and use the same material, and then kind of mimics the brass selector lever there too, which is cool. And what this thing's gonna look like is, use my table CAD here. So if we draw it in cross section here, you're going to have an OD like this, and then you'll have a wall thickness, and then what we want is we want a spherical seat and then a hole. Use my eraser. Something like that, right? So, and then this diameter here, so let's draw this proper cross section here for CAD junkies out there. So we got a spherical seat here, and then the trick is to get the ball to protrude the right amount, and that's controlled by this exit hole diameter here, or how far you penetrate with the spherical seat. Okay, so actually let's just we're going to take some measurements here. That diameter. Okay, and then this is a question mark right now. We know what this is because we know what the ball diameter is, so that's 188 diameter. So I'm going to go look for a ball end mill to create that seat, and then find a little piece of brass, and then we're going to go over to the lathe, and Bob's your uncle. All right. Contact. Still thinking about which tool I'm going to use. So let's see, 5mm. What is that? 190 what? 190 what? Boy, either way, it's not taking much out, huh? So here's the setup. We're going to run this ball end mill in, but we only want to run it into a fairly exact depth. Because it has to correspond to the length of the piece, and how it presses into the ratchet bit, right, into this, right. So this is the calculation to figure that out. I don't know if you guys can see that. How far in I need to go, which is this number here, 1318. So what I did was I figured out the 1318. I figured out the little cord that's left. Now let's see here. How do I illustrate that? So when when we have the radius, right, like this, okay. Yeah, it looks something like that, right? So I know what this opening is because I just drilled it. That's 180. And then, and that's how much ball I want protruding there, right? So since I'm driving it from this other end here, I'm driving it in this direction here. I'm going to zero on this surface and drive into the prescribed amount. And I know the length of this here. That's 0.2 in this case, okay? And I'm going to drive into the right amount, and then it should set that radius in just the right place for that ball. And if I did my math right. So I didn't lay it out on the computer, I just did it old school. So anyway, that's the general idea there. And what I'm worried about is when this gets pressed in, these walls here, that's supposed to be an arrowhead, will collapse on this, and it'll make the ball tight in that bore. That's what I'm mildly concerned with. So we'll see how it looks. So we've got our indicator here. Now we just have to zero on this surface here. So what I'm going to do is I'm going to use my handy dandy scale here. All right, until I just capture it. Like that. Okay. So I know what the thickness of that scale is. Let's see what's going on. Is this working? Yeah, okay. Now I'm going to preload this indicator a little bit, and then let's see, I have to extend, so that's going away, that's going that way, so I'm going to back this up 16.5 thou, something like that. That's the thickness of the scale. So let's see if I did that right. I went the right way anyway. And then when I go this way, yeah, okay. So that should be zeroed at that surface. Okay, does that make sense? I hope it does. Okay, so I'm kind of ready now. Let's go to town here. I'm gonna get in closer so you can see the fun. You guys ready? What's our number? 1318. Put the brake on a little bit. Oop. Gotta back up. 100, 10, 20, 32. Well, that doesn't seem like much, does it? Okay. Come out of there. Get this out. Don't forget to turn it to the diameter, Mr. Wizard. That little blue mark is just me eyeballing the length there. Alright, so this diameter's relatively important, so I want to make sure I get that right. 261, 2613, 2614. Okay. That's 0.2614. Okay. Yeah, that's pretty good. That's pretty good. I wanted between 252 and 253, so that's about right. Okay. Before I forget, put a little chamfer on that. I don't want to bang the camera. And then we are ready to dice that off and see what it looks like. I'm probably going to go a shade long because it's pretty easy to, I'll go 2 thou long. It's pretty easy to take it back, but extra hard to what we got. Alright, so there's our piece. Oop, oop, oop. Don't run away. There's our piece. There's the small end, there's the big end. So we got a little problem. This end mill that I use is cut a little undersized and it doesn't fit the ball. So yeah, it's pretty tight. So I think what I'm going to do, so I got two choices here. I can modify this piece, which is a mild pain in the rear, or I can make a new one, and you know it's pretty easy to make a new one. So well, this one's already made, so maybe
What do I want to do there? Yeah, it's pretty small. I don't know. It'll probably be okay. You know what? I'm gonna go for it. I'm gonna try modifying this one and see how that goes. I mean, it's not that big of a deal to make a new one, but let's try that since it's the trickier way to do it. So I'm gonna zero this a little differently this time. So we're gonna use the same tool here, right? But what I'm gonna do is I'm gonna use the carriage and the DRO, and the DRO to zero the depth here. Oh, I got the brake on. No wonder it's hard to feel. All right, that's pretty good. Okay, so let's lock that down. I'm gonna run back. Okay, so the carriage is up against the tailstock now. I'm zeroing, moving the tailstock forward 16.5 thousandths, which is the thickness of the scale. Okay, and then what I'm going to do is I'm going to push the tailstock up that exact amount. So technically, I zeroed the tool now, and now I'm going to zero it again. I'm going to go in my 131.8. Is that what it was? Yeah, 31. Okay. And then Bob's your uncle, so theoretically this should do it. Yeah, that should do it. Oh, well, okay, guess what we're doing? Well, I don't know. Wow, did that work? Actually, not too bad. It's garbage. Okay, we're making a new one. Okay, we're back where we were. Let's try that again, because that... Alright, so that's my 0. And then I'm going to go 16. Okay. And then, okay, that should be my 0. And it looks right. Got the eyeball bozo check there, and now we're going to plunge in our 131.1318 instead of 1 and 20, 30 right there. Go to the numbers. It looks a little shallow to me, but keep in mind we're only the whole thing's only 200 thousandths long. Did I do that right? Boy, it doesn't look right. That doesn't look right. Yeah, that ain't right. Well, sometimes it helps to review your math. Instead of adding, or excuse me, I subtracted instead of added. What we really needed was we have to go beyond the length of the part. So I subtracted. So that was a bad on my part. So my new number is 2682. So it took me a minute to figure out what I did. And 2682, is that right? 2682, yeah. So this just illustrates, you know, if you get stuck or something doesn't look right, start back at the beginning, and that's what I did, and figure out what you did wrong. And then, and you know, I'm a fan of sketches to kind of illustrate the dimensional stuff. But anyway, I think we're back on the horse. So now we're going to go in 2682. Alright, there's 100, 200, 6, 'Indicator travel. God dang it. Boy, this thing's just testing my patience here, isn't it? Alright, let's get back to 0. Get back to 0. I'm going to preload the indicator more. Alright. I love it. 100, 200, 50, 60, 65, 68. Alright. Alright, let's get out of there. Chop this little sucker off. Care about that. My God, this illustrates the complexities of filming, machining, doing math, the whole 9 yards, right? Should be it. Famous last words, right? Okay. Alright, let's see if we got it. Alright, after our little visit from Mr. Bozo, I think we got it here. So this is that 5mm end mill, and I'm pushing up with the spring, and so we have what looks like the right kind of protrusion of the ball from the retained side. So I think we're ready to assemble. I'm going to do, I soaked this a little bit, so I'm going to clean this, clean it out a little bit and make it nice, and then we'll assemble the retainer and the ball and the spring into the ratchet. All right. I think we are ready for assembly here. Get that in there. That goes in next. And that goes in. Let's get that lined up with the world. Okay. All right. Moment of truth. Let's go for it. Oh, yeah. Oh, come on, baby. A little more. Oh, no, 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 no. Oh. Well. What? Okay, that's still acting right. What's going on with my, oh, I wonder if the, alright, let me try something a little different there. So, I wonder if that ball, it's getting coil bound, because the length of that thing should be right. I need a little piece of tubing to go around it. Let me find something, see if I can push it in the rest of the way. Alright, I found a little piece of tubing so I can push this the rest of the way in now. Cross your fingers. want there to be an edge there. Alright, looks like it's doing the thing. So now the question is, does a socket go on it, right? Let's try that, see how that works. So far so good. Let's give it a try here. Alright, that's good. So full disclosure, I ended up having to remove the first one that I pressed in, and the ball was protruding a little bit too much, and so I just did that off camera. I just made a new one that allowed the ball to protrude less. So, but it seems to work fine now. So let's do. Yeah, I didn't want to. You know, it happens to the best of us, right? And but doesn't, I don't know. It doesn't do any good to see my frustration at Mr. Bozo visiting me. So okay, so assembly. Let's see here. I need a Phillips screwdriver, the little one, and then I'm going to put some lube on the ratchet itself, and then that goes that way. And I think we're done. So let me get a screwdriver and be right back. I'm just pleased that he still had these screws. I mean, to me, okay, so those screws are pretty special, right? Oh, where's the other one? Oh, there it is. So, you know, if you didn't have those, it always looks. So we're going to use some super lube here and lube up this ratchet. Let's see, I think we want a little on that too. And then, what? Yeah, it's not going to hurt to have a little in there. If I'm lucky, on a hot day, this will be in Chet's back pocket, and it'll weep a little bit of super lube. Okay. Oh yeah, it feels pretty tasty. Actually, you know what? I want a little bit on this face too. So the wear pattern on this is kind of weird, but I'm pretty sure this is the internal face here. Let's put a little on that, a little in there. Better a little bit too much, right? Yeah, I think that's fine. Okay, she goes back in. Oh, look at that. That's starting to look like something there. Well, I got lucky there. I happened to look at the back screen of the camera, and it was flashing the red of doom. Your battery's going down. But I caught it, luckily. Put the English on there. Okay, let's, oops, let me wipe the splits off of there. Wow, look at that. All right. Sounds pretty good. It's not an 80 tooth, but well, I think that's a success. Couple little visits from Mr. Bozo. All right, Mr. Chet, look at that, buddy. Pretty nice, huh? And it looks pretty much the same as when you gave it to me. I did wire brush this a little bit just to clean the crud off of it, but I didn't go crazy. I didn't do anything to the rest of the handle. I even left your Permatex or whatever that is on the handle there. Okay, so Ferret F-70N 1940 3/8 drive ratchet ball repair. So pretty cool. Okay, so that was a fun little exercise and another sentimental tool repair, I would call it. And Chet, thanks for the challenge. That was kind of cool. And I'll bring this back to you on Monday. And anyway, thanks for watching, folks. And like I said, check the description for the Bar Z Summer Bash down in Los Angeles, California. It's Friday and Saturday coming up here. This 21st and 22nd, I believe. And I'll put all the dates and contact info if you want to sign up and come shake hands. So I'll be there. I'm handing out stickers and other goodies, and I'd love to meet you and shake your hands. Thanks again for watching, and we'll see you next time.